Feeding your pets is an important and sometimes complicated process. If not done properly, it may have catastrophic results. There are 144 million pets in the United States. Of these pets, there's a significant portion that suffer from overeating and improper regulation of food. Our loving pets deserve the best possible care, and the key to returning our pets' love is to make sure that they're fed properly. 4 college students have developed a solution to pet feeding problems. So Brad, what is your solution exactly?
So our goal was to come up with a feeding system that would allow certain pets to eat from it and deny other pets. So this would operate off a RFID system where each pet would have its own unique collar, tag that you'd put on the collar. And as the pet approached the feeding system, the RFID reader would then sense the corresponding tag and either open or close the system for the particular pet. This system would also be on a timer so that the pet that does have access to the food, it would eventually time out on them and the system would close on them, preventing them from overeating and getting sick because of that. To accomplish this, we used a single servo which would act as the input to a Geneva mechanism, and the Geneva mechanism would have 2 output gears which would engage the 2 different systems, one to open the lid and one to lock the lid.
Can you clarify how the Geneva mechanism controls the lid and lock mechanisms?
The key to making the pet feeder compact and cheap to manufacture was to use only one servo. This was a challenge just because we had to figure out a way to operate 2 mechanisms from one input. The Geneva mechanism was our solution because the driver wheel is able to operate 2 independent Geneva wheels. One Geneva wheel would act as the input to the 4-bar mechanism controlling the lock, while the other acts as the input to the 4-bar mechanism controlling the lid. The special thing about this Geneva wheel is that it can accomplish these motions independently while only having one input. The 4-bar geometries were designed so that the smallest transmission angle is 45 degrees, giving us an efficient transmission of force.
How did you ensure the links were strong enough?
So one of the ways we ensure the links are strong enough is to analyze the forces on the links. But before we could do the force analysis, we had to pick a time that the lid would open and close in. And given that, we analyzed the velocity and the accelerations at given positions so that we could determine the forces. And based on our results, we found that the forces on the links were sufficiently low enough to use our 3D printed nylon.
With the calculated force in each member, we were able to look at the stresses in each member experienced. Nylon was chosen as the material for all links, which has a relatively high strength to the weight ratio and is easy to work with. Based on the dynamic force analysis, we found that the resulting forces were negligible because of the lightweight material. We found that the max stresses would occur if the lid or lock jammed, which is when the servo would produce its maximum torque. Tensile, shear, buckling, and effective stresses were then looked at. Comparing these stresses to the maximum allowable stress for our material, we found that the weakest link has a safety factor of 1.8, which is fine for our purpose.